What is going on, everyone? Tutorial Tim here at Design Academy, and we're going to be talking about pixel density and what that is exactly. So we're going to have an overview of that and then understand pixel density across different platforms such as iOS, Android, and for the web, and what that means for each platform. And I have the resource here. We can click on this link and just open it up, and once you have it opened up, you'll notice that it takes you to Material Design's documentation, and we're just going to be reading through this, and I'll be explaining this to you in certain scenarios in which you would need to understand this, and also just to broaden your horizons as a designer if you already don't understand pixel density. So once you have to design for a specific platform, you know exactly how to communicate measurements, for example. So say communicating measurements for Android is completely different than communicating measurements for developers on the web, or iOS or Android. So understanding how to do conversions, for example, you may have, say for example, I was building a Splunk product which is the company I work for, and this product's already been released, and it was a application shipping for iOS, and I myself had been a designer for the web, and I was not aware of how to translate pixel density from the web to iOS at the time, and essentially that is a scenario where you would need to understand this. So I was providing that example. So let's dive in, and we'll get into the rest later. So what is pixel density? Screen pixel density and resolution vary depending on the platform, and pixel density is just the number of pixels that fit into an inch is referred to as pixel density. So it's the pixels per inch. How many pixels per inch? So you may have seen, if you've printed paper out before or printed out some graphics or something, it asks you in the settings before you print to specify how many pixels per inch you want that to be printed at. So the lower the amount of pixels per inch, the lower the density is. And the more pixels per inch, the higher the density is. When you see that printed, or when you see it on a display. And they give you here in this documentation basically a formula on how to calculate pixel density, and it's just this equation where your screen density equals the screen width or height in pixels divided by the screen width or height in inches. And if you do that, you'll get your pixel density. So there's an example here visually, which is a really good example, where this high density display has more pixels per inch than the low density display here, and it zooms in on it, and you'll notice that this UI element, pixel dimensions appear larger on low density screens and smaller on high density screens. So the more pixels you have, the smaller it'll appear on high density screens, and the lower the pixel dimensions are, the larger it'll appear. So with that being said, we can jump on to talking about density independence, which refers to the uniform display of UI elements on screens with different densities. And density independence in material design is commonly pronounced as DIPS, which is the abbreviation DP here, written as DP and pronounced as DIPS. They're flexible units that scale to have uniform dimensions on any screen, and they can provide a flexible way to accommodate a design across platforms. So for example, material design not only designs for the web, but also Android and iOS. So they use this terminology DIPS, which is their way to have a common language in design and engineering to accommodate designs across several platforms. And Material UI's use of density independent pixels is to display elements consistently across screens with different densities on those different platforms. So here you can see a low density screen displayed with density independence here, where the low density makes it much more apparent, where you can see all these pixels here, which are all these squares. It's much more apparent on low density, and it is still apparent, but it is harder to see on high density, all the squares, due to the high density screen displayed. And now we can start to talk about the pixel density on a per platform basis, where this pixel density on Android, when you're developing on Android or designing for Android, you use dips to display elements uniformly on screens with different densities. So that's how you would measure it. And a dip is equal to 1 physical pixel on a screen with a density of 160. And essentially with that, and there's the equation here, again, being utilized. So essentially one dip is 1 pixel. So don't let me confuse you. You could think of it as simple as that. 1 dip is 1 pixel. But dips are used for measuring on Android. So that is important to note. And also scalable pixels, the abbreviation for that is SP, serves the same function as density independent pixels, which are dips. But for fonts, the default value of a scalable pixel is the same as the default value for a dip. But for fonts, the primary difference between a scalable pixel and a density independent pixel is that scalable pixels preserve a user's font setting, which is super important. Users who have larger text settings for accessibility will see font sizes match their text size preferences. And again, pixel density on iOS. The iOS base platform determines density using logical resolution, which means it just measures its units in points as opposed to pixels or dips. It uses points for measurement. And here, with their logical resolution, the points are scaled using a native scale factor, which is some technical knowledge for you to understand if you like, which just maps to a device's native resolution. So, for example, if you're designing for the iPhone X, you would design for a logical resolution of 375 points by 812 points. And when it's rendered, elements are processed by the graphics hardware using this native scale factor functionality to fill in the iPhone X's dimensions, since the screen is much bigger. So it has the capabilities of understanding those points and scaling them accordingly to the device it's being displayed on. And units, again, for iOS use points, so just remember that. And then, of course, pixel density on the web scales to the device's screen resolution, but when you're designing for the web, replace dips with pixels. So you can, when you're designing products on the web, unless specified otherwise by, say, engineers you work with and whatnot, you can just measure things in pixels. And that is all I have today for you, folks. Thanks so much for watching. I'll catch you in the next one.